The inverse of a relation R is denoted by R inverse this way, and it is a set containing BA such that AB is in the relation R. So with the previous examples that we've looked at, you just interchange the positions of the ordered pairs. So assuming we have a relation given as A1, B2, and C3, the inverse and given by R inverse is just swapping the positions of each ordered pair. So this is going to be 1A and 2B and as well as 3C. So you just interchange the positions of the ordered pairs and that gives you the inverse of that particular relation. And at this point, let's have a look at the domain and range of these two relations. The domain of R, A, B, C, and the range of R is 1, 2, 3. What about the domain of the inverse? This is 1, 2, 3. And the range of the inverse is also A, B, C. And at this point, I hope you see where I'm trying to arrive at. You would observe that the domain of the relation and the range of its inverse are the same. And on the other hand, that of the range and the domain of its inverse are the same. This brings us to the conclusion that the domain of a relation R is equal to the range of its inverse. And likewise, the range of R is equal to the domain of its inverse. You kindly take note of this. You don't need to chew this. If you solve more questions, you are going to realize it and you are going to know it by heart. Now, let's talk about some kinds of relation. In fact, for a relation we are talking about, all we did in the previous example is just like taking some elements A, B, C and mapping it to other elements like 1, 2, 3. What are the ways this could be done? We want to map each element here to some element here. So let's say this is A, this is B. We can do A to 1, A to 2. It creates a relation. Remember, we are moving in this direction. And let's say C to this. Another person could do let's say A to 3, B to 1, and C to 3 as well. And 2 will never get any object mapping to it from A to B. And that is absolutely fine when it comes to relations. So the kinds of relations we have one, a one-to-one relation. 2, one to many relation. 3, we have many to one. And lastly, many to many. Let's take them one by one. One to one. It means that assuming we have a set A, B, C, and we are mapping it to another set 1, 2, 3. One to one means every element, if it maps, should map to exactly one element. So we are from A to B. Every element in A should map to exactly one element in B. So we can do this, we can do this, and we can do this. This is one way. This is not the only way you can map it. Someone may choose to do A to 2, B to C, and C to 1. All we are particular about is that you should map one item to one item. And in this case, the set A becomes our domain, and the set B becomes our codomain. And inside this, we have our range. So later in this tutorial, we will look at the difference between domain and the range of a mapping. In this case too, this is the domain and this is the codomain. Okay, so this is one to one. No matter how you map them, it should be one element to one element. The next we are going to look at is one to many. And as the name suggests, if we have A, B, C to 1, 2, 3, and we want to define a one to many relation on it. This is our B A and this is our B. We want to define one to many. One to many doesn't necessarily need to be that each element maps to many elements. It should be that at least one element from the set A maps to more than one element in the set B. So if I choose A, I could do A maps to 1 and A maps to 2, and this is enough. In fact, if I leave it this way alone, this is one to many. B and C doesn't necessarily need to map to something. However, let's just add it. So we could add C to 3, and that's enough. That's fine. Another example, A, B, C to 1, 2, 3. We could do A to 1 and we could do B to 2 and B to 3. And in fact, we can even do B as well to 1. C doesn't necessarily need to map to something. This is one to many. So one element here from the domain maps to many elements in the codomain B. Note that one element here maps to more than one element in B. And that is one to many relation. Of course, we move on to many to one. We have A, B, C, and 1, 2, 3. We are saying many to one. So more than one element in A must map to just one element in B. So we can do A to 1 and B to 1. And C doesn't necessarily need to be mapping to anyone. However, let's just do C to 3. More than one element from the domain should map to exactly one element in the codomain, and that is many to one mapping or many to one relation. Another example is A, B, C to 1, 2, 3, and we are saying many to one. So at least we could have C maps to 2 and C maps to 3. And let's say A maps to 1. B doesn't necessarily need to map to anyone. However, if you do this, this is still many to one relation. Let's look at the final one, many to one. A, B, C into 1, 2, 3 from set A to B. We are saying many to many. So more than one element here maps to more than one element here. So if I take A maps to 1, I can map A to 3. This is 1 to many already. And again, I can do B to 1 and B to 2. In fact, C doesn't need to do the same thing. What we are particular about here is at least we should get one item that satisfies this condition, many. And the last one we are going to look at is many to many. So we have A, B, C mapping to 1, 2, 3. We are saying many to many from the set A to the set B. So when we pick A, we can do A maps to 1, A maps to 2. And this we see here is 1 to many, but we want many to many. So it means that we will combine, it's almost like combining 1 to many and many to 1. So on the other hand, we also do this and another one. So you could see that A map to 1 and C also maps to 1. So this is many maps to 1. And on the other hand, C map to 1 and C map to 3. And this is 1 map to many. So many to many is essentially combining 1 to many and many to 1. So this is it. As we proceed, we will look at more interesting examples. And these examples we have done here is called the arrow diagrams. So in the actual sense, every arrow needs to get, or every line needs to get that arrow on it. But I guess we know we are moving from A to B. So far so good. We've looked at what a relation is. We are continuing to have a look at some notations of a relation. And we have seen a few of them already. You know, we had R to be A cross B, and we said that this is equivalent or equal to AB, such that A from A and B from the set B. This is just like the set builder notation. So this is one way of representing a relation. And another one we saw was to list and another one we saw was to list the elements of the relation, say A1, B2, and C3. This is also looking like the tabular form as in sets. So this is also one notation. But the ones I want us to look at is the arrow diagram. And in fact, we've even looked at that one too. So assuming we have a relation, say A cross B, such that we have X, Y, given X from A and B from the set B. If our set A, let's say, is something like A, B, C, then our B, assuming is 1, 2, when we try to list our R, it is going to be A1, A2, and B1, B2, and it continues that way, C1, C2. Okay, so this is the tabular form. We have listed every member of the relation. We could have done this using an arrow diagram. So an arrow diagram this way, and our domain will be here, and as well as our range be here. In fact, it should have been the codomain. Okay, so you have A, B, and here will be 1, and so we have A, B, C, and here will be 1, 2. And what do we see? We see A1. It means A maps to 1. So we draw the line A maps to 1. And over here, we see A maps to 2. So A maps to 2 with the arrow pointing to this direction. Again, in this situation, we see B maps to 1. So B, and again, B maps to 2. And also, we see C maps to 1 and C maps to 2. So C maps to 1 and C maps to 2. Which kind of relation is this? You see that one element maps to more than one element here. So this is one to many relation. So this is the arrow diagram representation of a relation. It depends on the elements you have. Okay. Let's also look at the matrix form. or the matrix representation. From the same example, however, let's choose another relation. Let's say we have a relation like, say, A1, B2, B3, and say C3. Let's use this example. We will first list our domain and our range. So the domain of R in this case is A, B, C, and our range is 1, 2, 3. Now the matrix representation for the relation R is equal to, you form your matrix and you write the domain here and the range at the top. Now, where a particular element from the domain and a particular element from the range meets, you write 1. If there is no such case, you write 0. So in this case, our R will be equal to, we will form a matrix. It doesn't have to always be a square matrix. It depends on your domain and your range. So here, I'll put the domain here, A, B, C. And I'll put the range 1, 2, 3. Then I check. Is A related to 1? I check, is A related to 1? And yes, there's a relation between them. So I'll write 1. Is A related to 2? No. So I write 0. Is A related to 3? No. So I write 0. Then I come to B. Is B related to 1? Checking from this, no. So I write 0. Is B related to 2? Yes. So I write 1. Is B related to 3? Yes. And I write 1. So I do same for the remaining. Is C related to 1? No. Is C related to 2? And no as well. But C is related to 1. So this becomes the matrix representation of your relation R. Nice. Let's take one more example on the matrix. Assuming we have R given as 1A, 1D, 2B, go ahead and draw the arrow diagram for this relation and the matrix representation for this same relation. For the arrow diagram, I'm going to have this as my domain and also here my codomain. So in the domain, I have 1, 2, 3. 1, 2, 3. These are the unique elements available. So 1, 2, 3. And in the range, I have A, B, or A, D, B, C. So essentially A, B, C, D. Now in the first case, I see 1 mapping to A. And again, I see 1 mapping to D. And as well, I see 2 mapping to B. So 2 maps to B and 3 maps to C. And again, I see 3 maps to D. So this becomes the arrow diagram for this relation. Let's go ahead to do the matrix representation. My range is A, B, C, D. And my domain is 1, 2, 3. Do I have 1 relating to A? Yes, so I put 1. And I also have 1 relating to D. So 1 and D. I have 2 relating to B. So 2 and B. And 3 and C. And I also have 3 and D. Now the remaining spots becomes 0, 0. So this is the matrix representation for your relation. Okay. A quick reminder. We define relations to be an ordered pair A, B such that A is from A and B from B. The ordered pair A, B can be written as A related to B, A related to B in this form. So anywhere you see A related to B, it means that we are talking about relation.